Hello there, my name is Nick Barraclough. I'm president at AKCP. Today I'm going to be introducing to you the concept of the mold risk index and how it pertains to data centers and other facilities where you may be utilizing AKCP monitoring solutions. So first of all, what is the mold risk index, or we can sometimes call it the MRI? So basically it's the risk or the percentage chance or an index that indicates the likelihood of mold forming. Mold can form when there are certain specific environmental conditions, such as a high relative humidity and where your surface temperatures are close to the dew point values. So when surface temperatures are close to dew point, then you are likely to get condensation forming. When you get condensation forming, you're likely to get damp, which of course is conducive to mold growth. So that can be a challenge in data centers and in other facilities because it's a health hazard. But in a data center, the same conditions that are conducive to mold growth are also applicable to something called creep corrosion. So creep corrosion occurs when you have the same kind of conditions and you get condensation forming on some of your PCBs, for example, and it can cause corrosion of the electronic connections, the copper traces on the boards and so on. And this can be exacerbated when you also have a high concentration of sulfuric compounds and other VOCs and NOx, so volatile organic compounds and nitrous oxide compounds within the air. Because what can happen is these can begin to dissolve in this water, form slightly acidic solutions, which exacerbate the corrosion. The other thing that can happen is you end up with hygroscopic dust. Okay, so this is dust that absorbs water. Okay, now when you have dust that's absorbing liquid from the air, it then can dry and form a kind of paste, which is also conductive. And this can lead to short circuits and so on within your data center. So that's why the mold risk index is something that's important to monitor. And we can do that using AKCP products. So I've actually set that up here. There's a couple of different ways that the mold risk index can be calculated. One of them requires surface temperature and is slightly more accurate, and the other can work off of ambient air temperatures and gives you a more general look at the risk of mold within this room. So the two different forms of calculations, if we just get rid of this here, we have surface MRI, mold risk index, and that's calculated by taking the delta T, so the temperature difference between the temperature of the surface and the temperature, dew point temperature, okay? So the dew point and the temperature surface difference is the delta T in this case here. So if you have a temperature sensor that's mounted on the surface of a piece of equipment or a wall or whatever surface that you want to monitor, you can get surface temperature, and then we can also get dew point from our temperature humidity sensors, and from this we can do this calculation to give you the surface MRI. What you will get here is a delta T, and if that's between 0 to 3 degrees, then you have a high risk of mold forming or creep corrosion occurring. If it's greater than 3, then you have a low risk. Okay, so this is one way of calculating it. The other way, which we use ambient air and air temperature and humidity, as a slightly different calculation. So for this, we're going to say it's the RH minus 70 over 30 multiplied all of that by 100. So I think we put in some extra brackets here. Now, this is applicable when the relative humidity is greater than 75% and the ambient air temperature is between 4 and 40 degrees, I believe. So this calculation doesn't require the dew point, but it does require the relative humidity in the room. And it's more of a rule of thumb. And this will give you a percentage output. So rather than a delta T, the output of this calculation is 0 to 100%. Okay? The closer to 100%, the closer the probability of mold. So if you're hitting 100%, you've got 100% probability of mold. It's no longer a probability, it's a sure thing. But let's say at 30%, then you would have 30% risk of mold forming and so on. So the higher the percentage, the higher the risk. So let's go and take a look in our AKC product, how we can actually put this together. So we can do this using virtual sensors, which is what I've done here. We've got our mold risk index. This one here is using air temperature readings. We've also got a dew point calculation, which is used as the input to the surface mold risk, which we can see here. So the way we would set these up is we go into our sensors and you would go to virtual sensors, and you can see I've got them set up here. Let's take a look first at the dew point sensor. So for dew point, you would create a dew point type sensor. We already have that pre-programmed. So if we go to a new sensor type here, from the drop-down list, you'll choose dew point. We'll call this IT room dew point. And then you select the relevant sensor. So for temperature, I'm going to use our temperature sensor here. And for humidity, I'm going to use our humidity sensor connected to this device. And then we can input some other parameters. So the minimum value would be 0. And let's say the maximum value for this would be 40. Or 50. I don't expect it to go above 50 degrees in my data center. We'll put this in Celsius. And then you can set these critical and high warning thresholds as required. We'll say it's 45. And next, and the polling interval you can set as well. So once you've done this, you'll then have a dew point virtual sensor showing up that you'll be able to use. Okay, and that's what we've already done over there. We've already got this IT room dew point virtual sensor. Okay, if you no longer need this, you can just offline the sensor and say yes, and that will get rid of that sensor for us. Okay, so now we've created the dew point sensor. We'll go into our surface mold risk index. And what we've done here is we've created an arithmetic type Lua script. Okay, so to do this, you would again go into the list here and go to Lua script sensor. We'll call this IT room surface dew point. It's going to be an arithmetic type, a custom type of arithmetic. So for the surface, sorry, that's not dew point, is it? This is the IT room surface mold risk index. So we choose arithmetic and custom type. And for this, we're going to need to take the temperature of the surface. So we'll choose our temperature sensor that we're using. I'll use this one here. And then we're going to need the dew point, which we just created as a virtual sensor. So IT room dew point. And then we'll input the arithmetic here. It's quite simple. It will be A minus B. Okay, so surface temperature minus dew point. That will give us a delta T value, 3.8. So we're just above the critical threshold for this. So we go on next. This is an analog type sensor. Our minimum value will be 0. Our maximum value we could make 40. Low critical is going to be 0 to 1. And then our to warning will be 0 to 3. And then anything above there is going to be fine. So there's no high warning or high critical threshold necessary for this. As long as we're above 3 degrees, we have a low risk of mold. So once we've created that, it'll show up in the list here as our surface mold risk index. One thing that you might want to do is just change some of the status text. So this would be a low critical. We may want to change that to a mold risk warning critical. And we may want to make this one mold risk warning. And we'll go and save. So basically now, if it is above 3 degrees, it'll show normal. And if it's below 3 degrees but above 2, then we'll get a mold risk warning. And if it's below 1, 0 to 1, then we get a mold risk critical. So that's how we set up the surface one. We're going to do basically the same thing to do the air. So we would go into the mold risk index sensor that I created here, and we're just going to input that same calculation that we had earlier, this one here, but we're going to substitute RH with an actual sensor value. So that's what we have here. Our humidity sensor, A, minus 70 over 30 times 100, and that will give us an output. If we test this, we get 20%. So at the moment, we've got a 20% risk of mold given these current conditions that we have inside of this room. So that's how you set up a mold risk indicator virtual sensor here within the AKCP Sensor Pro Plus products. I hope that you found this useful. Do like and subscribe to keep up to date with our latest videos. And also as well, check the description below because we do have a link to a paper and blog that we've published which goes into more detail about the mold risk index and how it's applicable to your data center facility. So thanks for tuning in, and I will see you next time.